The James Webb Space Telescope was launched on Christmas of 2021. Webb is a joint collaboration between NASA, the European Space Agency, and the Canadian Space Agency. Webb consists of 18 hexagonal mirror segments, polished to perfection, which combine to make up its primary mirror. Ever since it was launched, Webb has been making breakthrough discoveries and giving mind-blowing results. And yet again, Webb has surprised astronomers with what it saw. This time, Webb has seen planets orbiting around dead stars, a solar system graveyard. Will that be the future of our own solar system too? Let's find out. Welcome to YouCurious. Discover more, know more. The life cycle of a star like our Sun is very fascinating. Currently, our Sun is around 4.5 billion years old. After our Sun is around 10 billion years old and has used up most of its fuel, which is hydrogen, it will balloon into a red giant, consuming Mercury. But as it expands, it will also get cooler. For about 1 billion years, it will continue to exist in this red giant phase. At this point, the blown-up red giant's core will not remain hot enough to oppose gravity, and it will give in to gravity. Its core will collapse, leading to an explosion of the outer layers. Our Sun, at this point, will engulf all planets till Earth. This Sun won't be very stable at this point, and will continue to blow off its outer layers. The hot core remaining after this stage is what we call a white dwarf. A white dwarf is the size of the Earth, but weighs as much as the Sun, making it a super dense, super hot object with immense gravity. Subramanya Chandrasekhar, an Indian-American physicist, gave an upper limit on the mass of white dwarfs. He worked out that a white dwarf which weighs more than 1.44 times the mass of the Sun won't be able to hold against gravity and will explode as a supernova. Chandrasekhar, after whom the famous Chandra X-ray Observatory is also named, won a Nobel Prize for his work on stellar evolution. Fun fact: scientists think that eventually white dwarfs cool down to a black lump of carbon called a black dwarf. But we have never yet seen a black dwarf and don't know if they can even exist. In fact, the conversion of a white dwarf into a black dwarf is one of the longest processes in the universe. So the observation of a black dwarf may give us a lower limit on the age of the universe itself. But coming back to solar systems, by studying other solar systems whose stars are at a dying stage, we can find out what our solar system might look like 7 billion years from now. And scientists used the fabulous James Webb Space Telescope for just this. This time, scientists made the James Webb Space Telescope point to 4 different white dwarfs to see what is left of the planets orbiting these dead lifeless stars. And 2 out of 4 white dwarfs showed a gaseous giant planet still orbiting them each, giving an indication that they survived their star's death. Interestingly, the calculations of astronomers show that these planets were at the same distances from their stars as Jupiter and Saturn are from our Sun. That's not it. In fact, wait for it, they even have the same temperature, age, and mass as Jupiter and Saturn. So we might actually be staring at the stark future of Jupiter and Saturn when we see these solar system graveyards. But talking about dwarf stars, just a month ago, the James Webb Space Telescope found an anomaly in a brown dwarf. This one being a brown dwarf, also called a failed star. A failed star is a celestial body made of gas that can't sustain nuclear fusion of hydrogen because it couldn't reach the necessary mass for it during its formation like a successful star. This one is designated W1935 and is located over 40 light-years from Earth. And the behavior of this dwarf star that perplexed astronomers is that it is showing signs of possessing an aurora. Auroras on Earth are known as the Northern Lights, and they are visible in Iceland, northern parts of Sweden, Finland, Norway, Russia, Canada, and Alaska, as well as southern Greenland. This beautiful phenomenon is caused by charged particles from the Sun striking molecules in Earth's atmosphere. They are usually seen only at high latitudes, because our planet's magnetosphere channels these particles toward the poles. Such auroras have also been spotted in our very own solar system on Jupiter and Saturn, and even on Jupiter's moon Io and on Saturn's moon Enceladus. But the reason the aurora is bewildering astronomers is because W1935 has no stars close to it that could be providing the charged particles to fire it up. The potential aurora over W1935 was indicated by infrared emissions from methane, spotted by James Webb Space Telescope. When methane emissions like this are seen over the gas giants Jupiter and Saturn, they are the result of their atmospheres being heated by charged particles from our Sun, thus creating aurorae. The same might apply to W1935 as well. With a lack of an external solar source to cause the brown dwarf's aurora, scientists believe that there may be some internal process occurring within W1935 supplying energy to its atmosphere. Maybe it's slowly beginning nuclear fusion of hydrogen, which might eventually lead to the formation of a successful star in a few million years. We will only have to wait and watch to see how this celestial riddle finally unfolds. Drop in your comments below and let us know what you think. And do subscribe and stay tuned to YouCurious. Discover more, know more.